Some of you guys know this stuff, and to motivate it, I'm going to use collections. What I'm going to talk about here is broader than collections, but collections is a good example of the use of generics. And some of you, how many of you know generics? Okay. One person just very confidently says yes, two or three say maybe. Okay. So we'll see how well you understand generics. Actually, I have two sections here. There's generics basic, generics advanced. I'm not even going to talk about generics advanced here. Okay. But the generics I'm going to show here will let you get the job done. So here's the problem I want to solve. I've got a string history interface that has an add element that takes a string as an argument. It has an element add that returns a string, and have a point history that's identical to this string history, except that I did a global substitution of string with point. Okay? And we don't want to do this kind of stuff, right? So, for those of you who don't know generics, what should I do to overcome this problem? What is something you can do today with the knowledge you have without generics to avoid this code repetition? Austin? Make it an object history. Okay, that's the beauty of subclassing or superclasses. So I could just go and have object history and create this interface. Did I lose something by going from those two interfaces to this one common interface? What did I lose?
The specific types that you were working.
I'm not. Say that again.
Like one worked with strings, the other one worked with integers, right?
With points.
Or points or whatever.
Yeah. So now it works with both. So this is good, right? More is better. No? Zach?
Well, like object element add, if you give the returned object, you're not able to call string the point method.
Okay. So if I put a point in, and then I want to retrieve the point back, and I want to do get x, I got to do this ugly casting, telling Java, trust me. Okay. And if you didn't make a mistake, that trust me is is an extra step, which is just bad. And why does Java insist that you do this casting?
To make sure that you're getting what you should be getting.
So what could I have gotten instead? If I put a point, okay, so I put a point, and why is it that you're not guaranteed that element at always returns point? So I could have also put strings. I could have created one history with both points and strings. That's not what I want. I want either all of them to be points or all of them to be strings.
You lose validation.
So you're losing validation. Okay? I'm going from these two specific types to this general type, and that's what you're losing. So we are stuck with this problem right now. Okay, and so let's invent now. Again, those of you who don't know generics, what could we do? How could we change Java? How could we just have our cake and eat it too here? Okay, let me. I write a method, calculate my current BMI, okay, and it says, here's my weight, here's my height, it calculates it, okay, and this says, okay, I'm anticipating, this is my calculated BMI, say after Thanksgiving, okay, so I'm expecting to gain a couple of kg, and I write another function to calculate that, okay. Now, if I showed you this stuff, and I did it this way, what would you say is, I'm duplicating code, right? If we decide to go and make it pounds and inches, I have to go and change both functions. So what would I do to get rid of this code duplication?
You copy the shared mathematical operation, put them in some method that returns double.
So I would have another method that returns a double, and how will that method be different from these two methods which also return doubles?
They would need to have
Parameters. Okay. So this value I want to change. Okay. So I want to basically say I would have this kind of method which takes parameters, and I would go and pass different values to this. Okay. That's what I would do, right? Can you go and relate that back to the previous problem?
Did you have like the object history that takes a parameter of what object you want it to be a history of?
So can I go and make my history take as a parameter a type? Right? That's what you want, right? You want to say, I want to create a parameterized history, and then I'm going to go and I'm going to have some variable that is a type. So every variable has a type, but now my variable will basically store a type. I'm going to use that variable here, and then just as I go and pass an actual parameter to a formal parameter, this will be a formal type parameter, and I will later go and assign actual parameters that are either strings or points. So if I do create such a type, that type is a generic type. Okay, it has type parameters. So I could do this, and need to replace type constants. Think of these as type constants with type parameters. Okay, I want a placeholders before, right? I could go and well, my animation went too quickly here. I could do this. I could go and put within angle brackets a type t, which indicates a placeholder, and use that t here to say that the same t, the t here is also the t here. I could use this syntax. So you want some syntax for formal parameter, and we've seen the syntax in grammars. You've seen the syntax many places, where when you want a placeholder, you want to give that placeholder a name. So you give it a name like t, and you put angle brackets around it. And you can see that my animations went too quickly, but I don't like this idea. What do you think would go wrong here? If this is the syntax, if this is what Java had done. Christian? Yeah.
The problem is so you say that there is a type, but you create an instance of history, you never specify a type.
Okay. So how do I go and give it different values? That's what you're saying, right?
Yes, yeah.
How-
You want to put a point or a string in there. It would be you have to, when you create history, you have to say, I would like to create history with strings.
Okay, so I could just go and say history. So we haven't even seen the syntax of that, right? We haven't even seen the syntax of how to go and give the assignments. Maybe I say history left. Again, I would say history. This angle bracket, string, angle bracket. Maybe I could do that.
You could do that when you initialize it, but you have to have it be a generic type for the.
So this is my way of declaring generic type. I go and say angle bracket t. This is not what Java does. That's why Christian is very uncomfortable with this. He's not sure why he's uncomfortable.
It's just T, it's not the angle bracket, it's just T.
Okay, that's what Java does. But this is me inventing. I'm trying to compete with Gosling here. Tell me why I'm so stupid.
But what happens if you try to type it in a type that's not really a type and there's some sort of error or something?
Okay, so the fact that I have angle brackets means it's type. And so that's sort of, that's the intention.
Don't you have to have the
Okay, that's what Christian's trying to tell me also. And I said, no, I want to show you that I'm also smart. It's not just James Gosling. So I'm doing something different. And I'm not. I'm being very stupid here. But tell me why Gosling did it right and I did it wrong.
So why should you not?
Yes, why should you not do this?
Isn't it just kind of like a type declaration? And so if you declare the type T of the public interface history part, then it will kind of trickle through, and then you just call T without an angle brackets.
So if you create a declaration, you don't have to. Beautiful, okay? So what you're doing is you're declaring things, and you are going to, and so that you can use them, and that's what Java does. But why is declaration important? You guys use JavaScript? Anybody? Yeah.
With this, could you not add an element to something that's string and then later get the element back in the index?
No, because the same T. It'll have to be the same T here. The reason why we declare things, why do we ever declare things? Why don't we use Python? Why don't we use JavaScript? Because we don't want to make errors. Okay? So what you're doing is declaring your intention. So what could go wrong here? I can accidentally say small t, or I can accidentally say AT. If I say AT, it says, oh, that's a different type. Okay, so when I created your grammar, I had to make sure that the non-terminal I used on the left-hand side had the same name when I used it on the right-hand side, because there was nobody to make the check and say, otherwise it just assumes it's a different non-terminal. So if I did it this way, I would not get the type checking rules on types, and I could go and make mistakes. So need a way to declare type parameters like we declare a variable, saying this is my intention, and if I use some other name in the body, then I did something wrong. So that is how we do it. That's what Kristen was saying. And what's your name? Okay. And this is your generic. Okay, we'll go and look next time at exactly what this means, but this is the syntax, and we'll elaborate on it next. Okay, let's start. Questions? Okay, so we were looking at generics last time, and we saw that we could go and parameterize our history by a type parameter. Okay, so history was an interface, and we wanted to not define a separate string history and a separate point history. Rather, we want to define one history that could be used as a point history or a string history. And the difference between string history, point history, and any other history is the type of the element in the history. Okay? And we didn't want to go and copy and paste code each time we had a new kind of history. So we said, let's parameterize the code by the type. Okay? And we looked at the sort of syntax. We needed a placeholder for a type, really, right? And we've been using angle brackets for placeholders, and that was done informally in grammars and other places. And we were going to do it more formally right now in a way that would protect us so that we won't make any errors. And so what we did was we went and when we were going to define our interface, we went and mentioned the types that will be parameters. Okay, just as when you declare a method header, you indicate all the types of all the parameters. Here you indicate and you name those parameters. Here, this is a type parameter, so we don't have to type the type. And we just name the type and say this is a type parameter, T. And then T can be used anywhere a type can be used. Okay, so add element takes an argument, small t, of type T, which is a parameter. Okay, so small t is a parameter to add element, and capital T is the parameter to the history interface. Okay, so this is something pretty radical from a radical departure from what you've seen earlier. The types themselves can be parameters. Okay, and this T refers to the same T, and it's this parameter. Okay, so before I expand on this, any questions? Seems pretty straightforward. Okay, so let's use some terminology here. So I'm parameterizing. When we talk of parameterizing methods, the method parameters, the thing that's being parameterized is a method. Okay, the thing that's being parameterized here is an interface, but in general, any entity, any scope that can define variables, can have declarations, can be parameterized. Okay, so it could be a class, it could be an interface, it could be a method. So even in a method, you can go and declare something to be a type parameter, and then all declarations in that method could use that type parameter in declarations. Okay, so so that's what we have here. Okay, it could be any block of code that has declarations, and such a scope is called a generic scope. Okay, so it will be a generic method or a generic interface or a generic class. Okay, so here's some terminology. Okay, so we know how to declare the formal parameter. Okay, so the T is a formal parameter here, and as we know from methods, a formal parameter must be assigned some actual parameter to make when this thing is used, when that parameterized entity is used. Okay, so we know there's a method declaration, there's a method call. This corresponds to a method declaration. So how would I actually, if I want a string history or a point history, for those of you who don't know generics, what kind of syntax might I use? So I want to declare a variable that's point history. And if I had a point history interface, I would say point history, point history. Okay, Austin?
New history, and then angle brackets once, and then give it some name, basically angle brackets.
Okay, so let me get this right. I just want to declare right now a variable. I don't want to instantiate anything because we don't know what we'll instantiate. We've got an interface only. So I want to declare a variable P, just to make it simple. which is going to be a point history. So I will say history,
History and then in angle brackets, point, D, outside of angle brackets.
okay? Fred, is that what you want to say also? Okay? And that's what Java says also. So you want a string history, you would say history, and now you have to go and assign actually a type constant, okay? So this is a type variable, this is a type constant, and I'm assigning string to t, essentially, okay? And here I'm assigning point to t. So just as you can have two different method calls to the same method that assign different values to the parameter, I can have two, what should I call this? We have method calls. What should I? So history is declared here, and history is done. What are we doing to history here? We declare methods and we call methods, right? I'm declaring history, and I'm doing what now? What's a good term? This is using it. So we'll call it elaborating it. Okay. I don't know if Java uses this term or not, but as far as I know, generics was invented in the context of a language called Ada. How many of you have heard of Ada? The language? And Ada, the language, is named after who? Who's Ada? The Countess of Lovelace. So what's her claim to fame besides being a countess? Okay, so she was associated with Babbage, who was another guy, Charles Babbage. What's his claim to fame besides being associated with Ada?
Like the first computer or something.
Babbage invented the first computer. Yeah. And, okay, I didn't quite hear what you said, but I assume you said that's what you were going to say too. So what's Ada's now claim to fame? What was associated with Babbage? It was professional. So she was the first programmer. Okay, so he was the first computer creator, and she was the first programmer, essentially. Okay, so after her, Ada, the language, was created, and generics were first introduced in Ada, and from what I remember, this is called elaboration. Okay, so we're going to elaborate this particular generic thing. Okay. Now I'm saying the string constant is being assigned to the type variable. Okay, just as a formal parameter, actual parameter is assigned to a formal parameter. Now, an actual parameter for method is assigned to a formal parameter at runtime, compile time, when? When's the method called? Okay, so the parameter is assigned to the formal at runtime. What about this? This constant is being assigned to this variable at compile time. Why compile time? Because that's what Java does, but why does Java do that?
So we can type check.
We can do type checking, and type checking is done at compile time. Okay, so this is a compile time operation. Okay, okay. So how many versions of history are kept around? I mean, I have this history and I have this history string, history point. How many variations of history are kept around at compile time, at runtime? That's the next question. So what's really happening when you say history string? What's Java, do you think, doing? Fred?
I guess it's creating an interface, which is basically the same as history.
So it's basically creating an interface that is same as the previous string history we had. So what we did was we took the history interface, we put it in an editor, and we did a global substitution of all T with string. Essentially, if we went from string history to point, we went to change all strings to point. Okay. So here, what it could do is take this code you have written, and without you having to do that, it just creates another interface where all T's are replaced by string, and here it creates another interface where all T's are replaced by point. Okay, that makes sense to you guys? I believe that's how Ada did it. Does it not make sense to anybody? Zach?
It makes sense, but it seems inefficient because you should just be able to say, have one history and then have different instances of T.
Okay, so you're saying you somehow keep a history with a parameter and then go and keep another tape somewhere else. This is that history where my parameter is assigned this value, and that's another history. Okay? And that will be more efficient, and I won't have to, every time somebody goes and changes history, I don't have to go and recreate the other histories. Okay? So that's what Java does. Okay? It really keeps a history here, and then it keeps, and these things are all stored in things called symbol tables, which are these data structures used by compiler to do compile checking, time checking. For those of you who do extra credit on the current assignment, I'm allowing you to define macros, and they are like method declarations. So those tables you'll keep to define them are like the symbol tables that you would have in a compiler. Okay? So it could just keep one declaration and have these two things point to that declaration, okay, with the parameters. Okay? Okay, so that answers the question, how many versions of this history are kept at compile time? Now, how many versions of history are kept at runtime? Or should be kept? I mean, one person knows the answer. They actually already answered that question earlier. Okay, so the answer is 1, 2, or 3. 1. So what happens to these guys? You just erase them from memory? That's what somebody said earlier. And that's what happens. Okay, so this is just a pure compile time activity. And ultimately, only one history interface is kept. If that only one history interface is kept, then what does this really T mean? T really mean in that interface? Object. Okay. So at runtime, T is object. At compile time, T could be string or point or whatever. We keep that information on compile time checking. That's purely a bookkeeping operation. And at runtime, there's only one T with object. Okay, that's a very important concept because, I find this confusing, frankly. I've seen languages where it's kept, where this information is kept at runtime, and I've seen languages where they just go and do what I said earlier, just replace. They create macros. They just replace all occurrences, so in all cases they're kept at runtime, and in one case it's parameterized, and the other case is not parameterized. Here at compile time it's parameterized, and at runtime that information is erased. Okay, and it'll cause. We'll see later that it'll cause you confusion also. Okay, so that's something that I believe Java invented. And I think it's wonderful. It's an invention, and also I think it's a little confusing. Okay, or maybe not more than a little confusing. Okay, so when is parameter assigned? At compile time. How many versions of history are at runtime? So a single version in which T is object is shared by all of its elaborations. Okay, at runtime. And assigning a value to type parameters is a compile time activity for type checking only, for bookkeeping and for operation, and the values assigned are erased at runtime. Okay, that's very, very important. Okay, so it's a compile time activity. Let's compare, so let's see what's happening here. I've got my history declared here, and an interface can be used in two contexts, right? One, when you're declaring variables, and the other context is when you're implementing classes. Okay, so we'll see how we use this, and the way you use them in both contexts is the same way. Okay, that you go and actually give a value to this particular parameter. What about this? Do you see any similarity between this and this? Here I've got arrays, here I've got history, right? And I'm saying I want a history of string, point, sorry, this should have been history of double. Okay, so I saw some confused faces. I was wondering why you were confused. So this should be history double. Okay, I'll try to remember to correct it. So, and what am I doing here? What's the commonality? Austin?
You're saying you want an array of type string pointer double.
So I'm parameterizing by type in both cases, right? Array seems to be like a parameterized type. We were using it, we never called it that, but it is. And so is this. So that's why using generics is perhaps not such a bold step. Then maybe it's just allowing us to define our own parameterized types, whereas array is the parameterized type that's given to us by the language.
So during runtime, if you had those three lines, history, string, history point, and then...
Hang on, so you're pointing here?
Yeah, I'm pointing there. So
okay.
At runtime, you're saying that the type would be erased, but they would turn into objects.
Yes, at runtime, they're all object histories.
Okay, so the first one, history, string, string, history, that would turn into a string object.
Yes, this would be an object, this would become an object, and whatever this is just all wrong. But yeah, whatever the parameters would turn into object at runtime. Absolutely. And my question was, if they are both parameterized types, is it the fact that all I'm doing here is allowing you as a programmer to define a parameterized type? Or is there some fundamental difference between this and this? And actually, I asked that question, you asked for this clarification, and that clarification actually was an answer to the question also, unknowing to you perhaps. So this is an object history, this is an object history at runtime, this is an object history at runtime. Yes, Zach?
Arrays, don't they stay like whatever they're typed as at runtime? So a string array stays as strings.
String array stays as string, point array stays as point, and double array is the tricky thing here. That double is going to, each array element is going to be double the size of basically a string pointer. Okay? So if it's an int array, it'll be of size 32 bits, each element. So that's how the array will be stored. If it's a double array, it'll be double that size. And if it's a string array or a point array, it's object size. But at runtime, arrays are keeping track of the fact that this is a string or a point. The information is not erased. Okay? And that's why things get confusing, because we have something that's kept at runtime and something that's not kept at runtime, even though they look very similar. Okay? So our arrays generics with special syntax, and generics and arrays are parameterized types, that is true. And again, to emphasize that there's a single version where t is equal to object, and whereas here different versions describe elements of different sizes perhaps. They can be same size, but they can be different sizes. And in fact, element type is kept at runtime. Okay? So there is a fundamental difference here, and you need to be aware of it. Zach?
For the generics, can you type them to primitive values?
You can't, because t is going to be object. Okay? And so you can use it by using that wrapper thing. Okay, where Java will do some conversion automatically, but you can't do it. Exactly for the reason I just described. Ultimately, t is object. Okay? And all Java is doing is saving you the overhead of doing casting at running. That's okay, basic, and it's just making sure that you're doing casting properly by seeing how you used it. And so it makes sure now that in string history you can only add strings, and in point history you can only add points. Okay, and that's basically what is making sure. Okay. Okay, so now I'm using history not to declare a variable, but I'm using it in a class implementation. And rather than a string history implementing string history, I just say a string history implements history string. Okay? So I didn't have to go and use a specific interface. I can just use a generic interface. Okay? And I want to go and do, I can similarly say a point history implements the same history generic with a different type parameter. And now I'm adding points here. Okay? So I'm reusing code. I'm reusing the code in interfaces. But what did I really do when I went from string history to a point history? I just changed all string occurrences in the class to point. Okay? So now that we know generics and now that we really are going, we know about type parameters, what could I have done to save, to avoid this copy and paste? I could have
Made it a generic class.
I said any scope, anywhere where you can make declarations, you can make that a generic. So I could make my class here a generic class. Okay? That's the basic idea. How to implement it is quite subtle, actually. And I'll be very surprised if any one of you gets it right. Okay? So now everybody's getting out from the laptop and saying, oh, really? I don't know generics, huh? Okay. So tell me what I should do here. I should go and change, rather than saying point, I would say a history. Right? And how would I make it generic? What would I say after that? Brackets with what? T, S, T? T? Implements, history, and then what comes here? Same T. Can I say S? Same T. Okay, if I'm a generic of T, then I'm implementing the same T as the one I'm passing here. Okay, good. This point changes to? Okay, I'm getting many answers here. Okay, so let's go one by one. Marcos, what was your answer?
Hold on, let me look at my code.
Oh, you don't look at codes here, you got to think. Okay.
Well, I did this before, and I did lists.
I'm using an array here. Okay. So you did it before, so you're cheating. Natalie?
I mean, I did it before as well.
Okay, let's see. I'll allow you to cheat. Okay, tell me what I should put here.
I did point, wait, it would be point with brackets around.
Okay, but hang on. This is going to be a generic history.
Okay, if that's generic history, then it,
And this is T here, I believe you can write here too, and I've got a tablet that I can write on, but I'm not going to try these dangerous things. So there's T here. So what does this become? Fred? T. Fred's answer is T. Anybody dispute him?
We just said that we can't make an array of generic.
So we can't make an array of generics. Now that's interesting. I did say that, and I said an array is not a generic. And so that if an array is not generic, can I go and put T here? What would that mean? If I don't put T, what do I put? Zach?
Well, can't you put T? The only problem would be that at runtime when it tries to put stuff into it, it won't be proper because let's say we have it as generic T and we want point. So the array would be of points, but then it tried to put objects into it.
So remember, this T information will get erased ultimately, right? So when I say T left bracket right bracket, we can imagine that what it does is what at runtime what would it really keep here? Information here, object. Ultimately, T will become object, right? So whether we say T or we say object, it's the same thing. Marcos, do you have an answer?
Well,
I used array lists.
Why? Array list ultimately is declared by some human, some mortal.
Right.
They're going to use an array inside.
Right.
I want you to tell me what that poor programmer had to write.
Yeah, it probably would have been an object. Most generic thing.
Okay, so arrays are not generics, but could we go and put that type, and so really when we put type T here, it becomes object, and Java could go and say, okay, I'll let you put T here. It's up to, but we'll ultimately have to replace this T with object. Okay? Or it could tell you, listen, let me make it very clear to you that there is an object. Okay? And Java actually does which one? You guys think? It could have done either way. And it really insists on this being object. Okay? So so this would also be then? Okay. And here, what do I put? Object or T? T. Why T?
So if you know that it's returning the type of your generic type like that, because it'll be able to be cached from object to that.
Okay, so this method could have been returning an object when it's elaborated, or it could be returning T when it's elaborated. And you want to make it very clear that we are returning T and not object. Okay? Here we're not returning any value, we're just saying how it's stored. And ultimately it's stored as an object, and we'll say, okay, let's make it very clear to you. Okay? And I make this what? T. Now, if I make this T, am I going to run into any type errors here? Can I just say return contents of index? What's contents? We agreed it was going to be? So what do I need to do here? Cast it as T. Okay?
Or just not using objects.
Which is ultimately is object, but we're saying this particular object we're going to treat as a T. Okay? And remember, this is what you guys had to do when you were going and when you didn't know how to use generics with vectors, and you were actually going and casting the value back. Okay? So, and any casting to be done here? When I say content size equals element, do I have to go and say T? T element? No, because T is an object. Okay, so we know it's got all object properties. Contents expects something to be an object. T is an object. Okay? And that's exactly what happens here. Okay? So that's exactly what happens here. Okay? So we are using the T in the element at and the add element. Okay? We are not using, and we're using the T in history also, saying my T is history's T. Okay? And basically what you're doing here is saying, it's like a method calling another method, and it's saying my parameter I'm passing to another parameter. Okay? So it's saying if I implement T, if I'm elaborated with T, then I implement history T. Okay? That's what it's saying.
Question.
Yeah.
So couldn't you do the same thing, instead of using T, just do object for everything, and then on the return only, typecast it back as the T that you pass it in?
Okay, let's get this right. Do you want a T here?
No, I'd say object there.
No, hang on.
object there.
First, one by one. Okay, I can't see where you're pointing. Okay? Do you want a T here or not?
No, I would just leave it as object.
If you don't make it a T here, then all you have is an object history. You cannot elaborate it then.
Right, but then you just typecast it to whatever you passed as the.
Okay, so you can always do typecasting, and typecasting is dangerous. Okay? You can do the bookkeeping in your head and say, look, I added an element of type T, so I can cast it back as T, and you make an error and you're in trouble. This is a very mechanical, stupid thing to do. Mechanical, stupid things, who should be doing? A program. Right? And that's exactly what you're making the program do. You're saying, look, this is what my intention is, and let not every user of history have to go and worry about this bookkeeping. And typing is all about this, by the way. I mean, if you use Python, you say, I want to keep this all in my head and I don't want to go and tell you what I'm doing because I know what I'm doing. And you say, look, let me tell you what I'm doing, and you do the how of enforcing it. Okay? Both Python and Java will have type at runtime information, and this one is just avoiding that. Okay? So that's why generics are used, and that's why Eclipse will scream at you if you use these generic types without going and putting the angle brackets, and it's saying you're being very, very bad. You're doing unsafe things. Okay? Okay. And the word we put object here. We could have, Java could have made it to be T and said that, look, you can say T here, you can say T here, and then you don't have to cast this T. It could have done that. It didn't do it. Okay? And I guess it didn't do that. Even though array is not a generic type, I can imagine a design where you allow this to be a T and avoid this particular typecast. But it's making it very clear that ultimately things are stored as objects. Okay? And that's what is making it clear. And we must tell Java which of the various possible array element types we want. And like I said, if we had just said T, you could have assumed this object. Okay? But it just says, make it very clear. Do you want a double? Do you want an object or whatever? Okay? And finally, a type parameter T must reduce to an object. And so that's what we make clear. Okay? So I'm saying the same thing in many different ways. Okay, so maybe we understand this. And now I'm using it the way Eclipse would like you to do it. I'm declaring string history. When I declare string history, I go and type it using an interface. And when I type it using an interface, I go and give it the type name. And when I instantiate it, I again say a history, and I go and say which kind of history it is, string history. And we know that when you pass a string to a history, it implements history string, right? So that's why this type checking works, because the two T's were the same. Okay, and now I'm saying point history is assigned a history elaborated point. Yeah.
What did reduce mean on the previous slide? Is that like a term? Or is that just
Elaborate. I'm saying reduce, elaborate, same thing. Ultimately, it becomes that. Okay. So when you do a formula, you reduce the formula to a smaller formula, and when you compute a formula, that's what you do, reduction, right? So that's a generic term that we got from math, that we are just going to the next step and reducing it to that. Okay. Okay. Here. Could I have put these three statements in add element? The first statement says element.char at 0. The second one says element.getX. And the third statement says element.toString. Given that we've got T there. Zach?
You could only do the last one because type object doesn't have a charAt or a getX.
So all you can assume when you are declaring a history is that T will be assigned some subtype of object. You cannot assume that it will be assigned a string. You cannot assume it will be assigned a point. All you can do is what Zach said. Okay? You can do toString. You can only invoke object operations on something declared of type T, where T is a parameter. Then? Sorry, a little louder. You can't use primitive types, okay? So you can't say element plus 5 or 5 plus element, okay? Because it's got to be object. Think of T as object, basically. All the rules that apply to object apply to T, yeah.
So what if you like elaborate on a double type?
You cannot elaborate with primitive types. You can do that with arrays. You cannot do that with. Yes. But is that a real problem? Just convert the int to a class integer and then elaborate with integer. And at one time you had to do this conversion manually, and I really thank the Java guys who have started doing it automatically for us. Okay. So only object operations can be assumed because the only guarantees that T will be elaborate with a subtype of. Okay. So the parameter of history is used as a parameter of history. Okay, I just want to make this very clear. And this is like my parameter weight being passed to calculate. So I've got two calculate BMIs, one that just takes one parameter and one that takes two parameters where the height also is flexible. And my inflexible one takes its weight parameter and assigns it to another formal parameter, which is this one. Okay, so I'm basically passing the buck. I'm reducing the call to another call. Okay, so that's what's happening. Okay, I just want to make this very clear, and this is the analogy with method calls. Okay, could I have done? Supposing I had my interface T here. What if I said a history, a type, implements history T? If I type this, what would Java say? Fine, or complain, or use some different semantics?
T isn't ever declared there.
So a type is declared.
Yeah, T isn't.
So is there a problem? What's the problem?
It doesn't know what T is.
It doesn't know what T is. It's an undeclared variable, essentially. See, this is where T was declared. This is where history was declared. This is where history is being used. When it's being used, it expects a value. And basically, a type here is what you declared, and this is basically an undeclared variable, if you will. Okay? And that is similar to my going and saying, calculate my BMI, my formal parameter is weight, and I go and say calculate BMI W, and it says W is not declared. What W do you mean? Okay, even though there is W here, it doesn't know that this is that these are the same values. It doesn't even know what value to put here. Okay, so that's important. Okay, is this legal then? Can I say can I declare history to be of type T and have a history, a type, implements history, a type? Is that legal? It's legal. A lot of people are saying yes. Just we can name our parameters, and all we are saying is whatever I get in a type is what I pass here, and I can name it whatever I want. Okay, and that's like my formal parameter being called weight, and that is passed to a formal parameter called W. They declare it as a W. I call it weight. That's my business. Okay, I can do whatever I want to. I can name the same thing differently. Okay, and in fact, why would you do this? By the way, I can have one interface I1 with parameter called T, another interface called I2 with a parameter called T, and then I can declare C T1 T2, which implements I T1 and I T2. Okay, so I can't just use the same name that they used. I shouldn't have to, and this shows you why. Okay, so that's basically what's going on. Okay? So that's, you're just passing the parameter value. Questions? Okay, so I think we understand genetics pretty well. Like, this is the depth to which I'll go. There's much more depth I could go to, and maybe if we have time, I will. Okay. Let's just go and see how we can use what we've learned. So I have this history T declared, and what am I doing here, by the way? I don't know what I'm doing here. Actually, I didn't intend for this slide to be around. But what do you think I was trying to do here? So I'm trying to, so those of you who use generics, do you enjoy typing those angle brackets? You do? You're touch typists. I just can never remember where it is. Okay? I hate them. I love the idea, but I really hate the angle brackets. And whenever I can get away with it, I don't use them. Okay? Just because I'm a bad typist. Okay? And this is one way I could get away from this. I could go and say, I'm just going to declare once a point, that point history extends history point. Okay? This is where I went wrong. And then I will just use point history rather than say history, angle bracket, point, angle bracket. Okay? I'll use that as shorthand, and that'll solve my typing problems. Okay? That's something I could do. Okay? I'm not saying you should do that, okay? But that's something you can do. Okay, now, as it turns out, a long time ago, I showed you a point history which did not have this kind of add element. It had add element with x and y coordinates, and there was a reason I did this point history. I was allowing you guys to add elements using object editor. Object editor will handle methods that take object types as arguments. I never told you how it handles that. It's complicated just because it has to be complicated. Okay? And I went and said, okay, just put x and y and let your add element create the object, because creating objects interactively is a pain. Okay? So this is the point history I had. So I can't quite use the point history even if I went and typed this correctly, because I want, let's say I want this kind of point history. Don't debate too much why I want this point history. Okay? If I want this point history, clearly I cannot elaborate history. Okay, I have decided to change it to my add element method. I do not want this add element method, and I want this add element for whatever reason. I kind of give you a reason. It's not the most convincing reason, but let's just take that as a good reason. Okay, so I certainly can't use history, but does that mean that my implementation of point history can't use the implementation of history? Okay, and I have this history. And I really don't want to go and, if I can, I want to avoid writing some of the code that I would use to implement my different kind of point history. How could I go and use this code? And let me just give you some choices before I know some of you got the right choice already in your head, but let's go and look at some choices. So I want an implementation of this. I've got this class. So how do you reuse this code in point history implementation? And could I just go and do this before we look at the wrong answer, a right answer? This I'm hinting is a wrong answer. But could I have done this? No? Okay, so I'm calling my add element here that takes t as an argument. I'm passing it a point. And can I assume that t was elaborated as point? I cannot. Exactly what you're saying. Okay? So even if this was correct thing to do logically, in the sense that if the is-a relationship is preserved somehow, well, I guess that's what I'm saying, that basically this is a history of some type t, and we can't assume that it's a point history. Okay? So I can't do this for exactly the reason that Austin just said. This method makes no sense for non-point histories. And this history could be elaborated as a string history, so we can't do this. Can only pass to add element a t. Okay? So we understand this type checking a little better. Okay, what if I do this? I say a point history extends a history of points. And I do my add element there. First, will Java let me do this? There's nothing, that seems fine. I've elaborated a history properly, and I can then go and add any method I want to. So Java is not going to complain. Okay. Now, is there anything that went maybe wrong here? What methods, what interface does a point history implement? It implements point history.
If you don't have point history extending history in brackets point, you're missing the add element that you get from a history point of adding the element of
Point.
an object.
Okay. So what am I really doing here? I'm implementing two interfaces, right? I'm implementing point history, and I'm implementing history with point. Okay? The size method is the same, it's a set. Element add is the same. Now I've got two add elements. One that takes point as an argument, and another that takes two x and y. So is that what you were saying has happened? Now you may say that's fine. It logically makes sense. Both add elements, make sense logically. But I was insistent, and I was very defensive earlier. Just assume this is a good rule, that I only want my point history to implement these methods. I do not want this add element method to be implemented for whatever reason. I gave you a weak reason, and let's assume that's a strong reason. If that is a strong reason, what can I do? I really don't want that add element point. But I want to reuse the code. So what could I do? Inheritance is not going to do it for me. Before you guys had inheritance, were you not being able to reuse code? You could reuse code even then, right? So let's go and see. My point history here is a history. I have the is a relationship between a point history and a history. What other kind of relationship could I have? If I had a has a relationship, could I somehow reuse the code? Remember when we guys talked about a line and point? A line is not a point. A line has a point, and then it can use the point functionality. Right? So I could go this, and I have now contents is a history. I have a contents. And what did I do? I have my add element method, which I go in. I implement this add element method by calling the add element method in contents. I implement my element add method by calling the contents element add. I implement my size method by doing contents.size. I've had to do some work, but I didn't have to go and implement the logic of add element or the logic of element add or the logic of size. Okay, so I've reused the code. And
Didn't point history extend the history of points?
no, point history does not extend history point. That was my whole point. Okay, that I was going to do add element xy and not the generic add element. Otherwise, my life would be very easy.
Couldn't you just not implement the point history interface and override those elements?
So could you, when you're inheriting, somehow say, I don't want this method. Replace that add element method with this, okay? And that's the thing about is a. If you're saying something is a, you better be is a. Which means you better get everything. You can go and change the implementations. You can override. When you override, you go and use the same method signature and have a different implementation. What you're talking about is overloading. You'll keep that add element with one list of arguments, and you'll have another add element with a different set of arguments, and now both add elements are visible. Okay? And logically speaking, it's fine in this case. But I'm just insistent because I want an example. Okay? I'll show you a better example just in a couple of slides, where I'm insisting that I don't want that add element. I want to add element only one way, not the other, which doesn't make sense that much. Okay? So I use the word delegation here. The English word delegation here, does that seem appropriate? There was, in my previous slide, I had inheritance. Now I'm contrasting that to delegation. The is a involved inheritance. The has a involves delegation. Okay? And does the English word delegation make sense? And if it does, who's the delegator and who's the delegate? Who's the delegated? Zach?
The point history is the delegator, and the delegated will be history in the brackets.
Okay. A history is my delegate, and this is the delegator. This is the guy who says, I don't want to do work. I pass the work to somebody else. I delegate it to somebody else. Okay. So if you are delegating work to your subordinate, okay, then you have some access to the subordinate. You are not your subordinate. Okay. So a manager is not a subordinate. A manager delegates to a subordinate. That's the philosophy here. Okay? So a point history is not a history according to the rules I've defined. Okay? It's delegating to a history. So this is the delegate, and this is the delegator. Okay? This is a very technical concept. You know, you Google, you'll see inheritance versus delegation. And the history of object-oriented programming has gone as follows. The very first language that I told you guys did not have an inheritance. And anybody remember what the language was and which decade it was invented in? Smalltalk. And it was invented in which decade? Okay, so you got one of those two things right. So there was a language in 60s that was invented. It was called Simula 67. And that was the first object-based language. It didn't have inheritance. Smalltalk had inheritance. It was invented. Smalltalk 80 was the first language that came out. So it was invented before 80, but it was released in 80. And it had inheritance. And when inheritance was discovered, people were just so excited by it. I mean, people literally would, they would have tears coming down their eyes saying what a beautiful concept it is. It was beauty. Okay? And they would use inheritance wherever they could use it. And then people matured and said, hey, you're using inheritance, in places you shouldn't. And the current fashion is, whenever you use inheritance, question it, because delegation might be a better answer. Okay? And even when the easier relationship is logically followed, you get more flexibility when in interfaces, inheritance is fine, no problem. In classes, beware. Do not go and follow inheritance. Use delegation. That will give you far more flexibility. Okay? So I used to spend a lot of time on delegation, but then something else gave. I never did threads in those days. So something had to give. So this is my 1 or 2 slides on delegation. Okay? So delegation is a very general concept. Wherever you can use inheritance, you can use delegation. Okay? Let's go and look at the particular form of delegation we have here. What is size really? What is this method? What is the relationship between the size method here and the size method here? One calls the other, doesn't do anything else, right? It's just a proxy of forwarding it. Okay? So, forwarding proxy again. What is this guy doing? I mean, it's calling. But what might you say, use some English word to contrast it? Yeah.
Sort of, it's taking its own parameters and turning them into a form that the history.
Excellent. Excellent. So it's taking one form and turning it into another form. And what's some synonyms for turning that you could use? What's some object what kind of entity would you call something that turns one thing into another something? A turner? Converter? Sorry, I still didn't get it. Factory? No, this is not factory. Transformer, or you go to Europe, you want an adapter. Okay? So this is adapting. I mean, that's just, all these words are good words. This is the word that's typically used. Okay? And because this adapting method exists here, we'll call this delegator an adapter. Okay? And this is a general pattern that you see. It's one of the design patterns that people talk about. Factory is another kind of pattern, which, again, I've covered in this class at one time, but I won't get a chance probably to do it. And so this is adapting. Okay? And I'm showing this through colors here. The idea is that we have something colored, what, purple? I don't know, this color. And we have something that's blue, something that expects blue, and something that expects this color of this shade of blue. Okay, and this guy has an interface that talks this color to this guy, and that talks this color to this guy. Okay, so from the point of view of this blue guy, this is blue, and from the point of view of this guy, this color. Okay, I'm not 100% sure I'm making sense here. Okay, but that's the basic idea. You're converting one to another. Okay, and so this expects a purple guy here. That's what I'm trying to say. Is this color purple? You guys who are better, purple? Isn't purple more reddish than this? Okay. Okay. So now I can name colors. Okay, without embarrassing myself. Blue, purple. From this guy's point of view, this is blue. From this guy's point of view, this is purple. And that's like your 240 volts being converted into 110 volts. Or actually, no, that's more like a transformer. It's more like an adapter where you have these kind of pins versus these kind of pins. Okay? So, in general, you have a client, an adaptee, and you have an adapter between the client and the adaptee. Okay? And that's a very, very common pattern to use. And this is just saying in text what I just said, so I'll just fast forward. Okay, and I'm showing you another use, a better use of adapter pattern. That was not really a good use, but it was a simple use for me to present. What am I doing here? I've got my string history, implementing history of string. Remember, my history of string just had 3 methods. Okay, those are the 3 methods I have here. I'm doing, I'm declaring, now that I can use arrays, I'm using arrays and array, and now that I can use Java collection types, I'm not using arrays. I'm using the list type here, and I'm using the array list type here. And those of you who didn't know this, the list and array types that I showed you earlier were actually generics. Okay? And I'm saying my list string contents is an array list of string. Okay? This is the class, this is the interface, and my add element just forwards this method to contents. My element add it just changes the name, and my size goes and uses the same name. Okay, so this class, a string history, is another example of an adapter class. And now I'm adapting. I'm changing the element add to get. That's one adaptation, and I'm doing something more also, right? By the way, so I've done this, and adapter pattern often used with array list and vector. I could have done this also. A string history extends array list string. Why didn't I do inheritance, and why did I do delegation? Why did I build an adapter, and why didn't I just go and subclass array list? And there are lots of methods of array list you don't want in history. This is a much better example. What's an example of a method that you don't want in history? Add all, I could imagine conceptually in a history that I'm adding multiple elements at one time. That doesn't seem too bad a method to have. Remove. I do not want a remove. This is history. Okay? So this is a much better example. Having one variation of add element and not another add element was not such a good example. This is a really good example. Okay? And I really recommend that you don't use array lists and vectors just directly. You build adapters for them. And typically adapters, that's where the adapter pattern is used a lot. Okay?
So are the terms delegator and adapter interchangeable?
Are the terms delegator and adapter interchangeable? What do you guys think? Zach, no. Nathan, no. Why not no? Why no?
Delegator is an object with both adapter methods and avoiding functions, but adapted, then its own parameters might be changing.
Okay, so you're saying an adapter just has adapted methods. See, there's an adapter method we talked about and an adapter class we talked about. I think you're getting a little confused between those two. So my history had an adapting method and two proxy methods. But also it went and filtered out a lot of methods. So the class is adapting in two different ways. One by having an adapter method, and second by not having many of the other methods. Okay, Zach?
Well, like an adapter in general would be a delegator, but you can have a delegator do things that isn't adapting.
I could have a delegator that did anything it wanted to. Okay? It could be a transformer converting 240 volts to 110 volts, which is not an adapter. Adapter is more like you think of as something that goes from 3 pins to 2 pins, perhaps. Okay, or from the American pins to the European pins. Okay, so, or it could go and do, it could just add any kind of functionality. A line delegates to a point. It doesn't adapt point, but a line has a link, has a point, so it's delegating some of the functionality to the point, perhaps. Okay, so delegation is a much more general concept. Delegation is is competition to inheritance, and you can adapt. Yeah, that's the way to look at it.
So in an adapter class, do all the methods have to be adapted?
In an adapter class, do all the methods have to be adapted? We saw that in a point history, some of them were forwarding and some of them were adapting methods. Okay, adapting methods is kind of my terminology, just to make sense of things. Typically, the adjective is used for classes and not methods, but you can imagine it being used for methods also. But an adapter can have adaptive methods and it can have filtering methods where some methods are just not made visible. Okay? So this is not what you want to do. We are exposing only history methods in the first case, and in the second case it is. Okay, we've seen that history can be generic, list can be generic, array list can be generic. We had a table interface. Can you imagine this being generic also? And what would be the types? What would be how would I go and declare a generic table? And you guys have to do this.
You probably create a type from the keys and the values.
Okay, so two types. A bold new step here from one type to two types, right? So key type, value type, and I've got key type, key, value type, value, and my get takes, this should be key type, and it returns a value type, okay? So I've got a generic table. And this is the kind of interface I want you guys to implement in your next assignment. Okay, and you know enough to do it now in your current assignment, okay? And in fact, I showed you an example of map and hash map earlier, where we went and put some names and their number of tournaments they had won, the Grand Slams. And here I was not being very safe. And if you ever type this in, Eclipse was going to scream at you. And if you don't want it to scream at you, and it screamed at you because it said, here's a generic, somebody took all the effort to go and declare generic types, and you're not even, so what does it really mean? Actually, a map and a hash map are both generics. They take those two parameters I talked about. I'm elaborating them without any parameters. So what does it really mean for those of you who don't know generics? What could it mean? Object. So if you omit, it means object. Okay? And it's screaming at you and saying, you should do better. And you don't want it to scream. You go and say, okay, I have a map of string and integer, and string and integer here too. Okay? So our hash maps are also generics. So generics are all around. Okay, that's why I really wanted to teach you guys generics. Okay, now what did we see as generic examples? History, array list, maps. They're all collections. So the next question for you is, are all generics collections? When I was telling you the definition of generic, I said it's a scope. I did not say the scope is going to be a collection. I said it's a scope. So theoretically, any scope could be generic. But can you think of an example where something that's not a collection would be a generic? Something that you might have, some kind of type you might have seen in this class earlier or not seen. I don't want to constrain you here too much. The class object, I didn't quite talk about the class object, so I don't want to get too much into it. But yes, you're right. Class object is generic. Zach?
Like in our assignment, we make tokens generics, and they're not a collection, they're an individual object.
So my token class, remember now, as there's no mystery any longer, the token is going to be an abstract the class token or the interface token. So what would be the so the class is already an abstract class, right? What would be parameterized by? So we have you guys remember better than I do what the token methods were, but there was the get string representation. There was a get string representation. So that's just string. Everybody has string. There may be some other methods, but I don't really. I wrote the assignment and I just forget about them.
I don't know where I was.
Yeah, but you're right. There's somehow you want to use that code. So think further. Any other things? What about yeah, Nick?
We've had lines and points that might be Cartesian or polar. Like, you know, if you type that
Okay, the
in,
cut.
you can define it differently because they're implements differently, but they take different types for it.
So what we had was a polar line and a Cartesian point, a Cartesian line and a Cartesian point and a polar point. They both implemented point, but they had different implementations. So, and actually they were primitive values. So that's another reason why we couldn't quite use generic, but they were just different implementations. Not that I was doing cutting and pasting. Andrew?
Back to the tokens. We had the number word and string tokens. So there was the get string, but also there was the get number on the number token. There was get word and the word token. So that could have been a generic
Good.
type. So we just get value, which we return the integer for the.
Excellent. Maybe that's what Zach was thinking. Okay, that you could have just had a get value and parameterize that by the kind of type. Excellent. Okay. Anything else? How about your? So I asked this question the last time I taught this class. I had a more complicated answer here because I had done something called visitor, so that's what I was thinking of, and somebody said observer, and so I thought about it. So I have a counter observer that has an update method, which takes the observable as an argument. I have a BMI spreadsheet observer, which has an update method that takes a BMI spreadsheet as an argument. They both update. They're both logically the same thing, right? That the observable has changed, and the update method is being called in the observer. And how could I parameterize this? So I would have an interface called observer that takes as an argument
The class that's going to be updated on.
the observable. Okay. Java has an interface called observer, which is not generic. So I wanted to distinguish this interface from that interface. So I'm calling it generic observer. I'm not suggesting that every time you define a generic scope, you call it generic. Okay. And we will just go and have update observable. One interface, economy of interfaces. This is just like your token example. Okay. And I could then have a counter observer, implement generic observer counter, a BMI spreadsheet observer, implement generic observer BMI spreadsheet, and this guy would go and put in his update method BMI spreadsheet. This guy would put in his BMI update method counter, and because he puts counter here and this puts BMI spreadsheet, you can use counter specific values. I'm not sharing the implementation of the observer, okay, because they're doing different things depending on what the observable is. So I'm just changing the implementation of the interface, not the class. Okay? So both of these classes implement the same interface. It's like your different token classes implementing the same token interface. Okay? Okay. Now I'm going to pose to you guys a question. If you could I implement this class? This is a class that I'm calling a BMI spreadsheet and counter observer. And I'm implementing generic observer, BMI spreadsheet, and generic observer counter. And I have an update method with BMI spreadsheet and update method with counter. Fred?
I was thinking you have code duplication too.
Sorry?
No, I don't answer.
Johnson? No. Sorry? John. I'm sorry. Okay.
Theoretically, you could, but because Java has type erasure, you can't implement both those interfaces because they get reduced down to generic observer.
So you're saying theoretically it makes sense, but because Java does this erasing of type information, somehow this doesn't make sense?
Actually, it might work.
Andrew?
I think from where he was, because it's type erasure, they'll both reduce down to objects, so you'll have both of them. Actually, yes, because it'll end up you'll have two identical method stubs that are both update objects, and just going to.
Hang on. Let's get this right. We are talking of two things here: the interface and the class. So ultimately, what will convert into one method?
The interface.
The interface has only one. As far as both of these interfaces have only one update method with object.
So
And that means I can't have this kind of stuff here?
that kind of thing, the interface is what only declaring object. So both of those, right? There is no update object.
So somehow there is no update object, but when there was only one interface, there was no update object here either.
Can you find a way to talk to us about this corner?
Sorry?
Try to find a way to talk to us out of this corner.
You guys are right. And you're right there. I mean, I'm just trying to make you complete your thought rather than complete the thought for you.
Does it have to do with synchronization? Like, how would it know which one to, you would have to like call one after the other, but how do you prioritize it?
So even though this guy could have two methods here, how does it know how to call? Zach?
Yeah, is at runtime, it sees what it gets as an object, right? So then it's trying to decide between putting an object in two different update object methods.
And which one should it choose? Okay, so between the four of you, you've got the answer. Okay? And, okay, firstly, this is not going to be allowed. Okay, so let's get rid of the mystery here. Okay? And you cannot implement the same generic twice with different parameters. That's just a rule, whether you like it or not. Okay? You can just consider it as a rule. And why not? There's only a single interface method that exists at runtime. Okay, that's what Zach and Keenan was saying. So when I go and say generic observer counter, and I say counter observer equals new BMI spreadsheet and counter observer, and then I say counter observer dot update counter, there's only one update method in the interface, and it doesn't know which one of the update methods to call here. Okay, so at this point, it's got to decide which one, and there's two of them matching update object, so it's got a decision. It doesn't know which one. Should it call both? Should it call none? And so it just says you cannot implement the same interface twice. You can implement it twice with the same parameter, which is kind of silly to do. But if you're implementing it with different parameters, you can't. Okay? Okay, good. So you guys know quite a lot about, this is called dynamic dispatch, where it looks up the interface method and goes and says which class method corresponds to this interface method. And so that's this dynamic dispatch will get very confused at runtime. Okay, we'll do exceptions next time. Okay. So we look at generics, and in the context of generics, we look at this example, and we couldn't use the generic directly. We had to build an adapter to the generic, and adapter is a pattern. And and I just want to show you, explain to you. I want to bring in two things here. Firstly, that generics exist. So you've implemented your own generic. That's a big deal. You know, a lot of people who claim to know generics have just used generics. They've never implemented a generic class or interface themselves. But these do exist, and you should, you know, after you finish this class, in fact, after this assignment, after the current assignment, which is number 10, I guess, from 11 onwards, whatever new problems I tell you to do, you can use these classes that I'm just talking about. Okay? And vectors and array lists for generics. And there's a whole hierarchy that connects these guys together. And now that you know what hierarchies are like and what abstract classes are, you can understand this hierarchy. I might have a point history. Okay? Add element takes point, element add returns point, size is same. Okay? And how did I create that slide? I went and replaced all occurrences of string with point. Did it. Okay? So won't it be nice if I could share? I don't do this cut and copying stuff. I could somehow have Java help me with that. Okay? So first, those guys who haven't seen generics, most of you, be inventors. Tell me how Java could be extended to go and. If you've seen, then no memory, please. Think. Yeah. No, there's no array here. I'm going first with interfaces. It's much easier. We'll go to the implementation later, which is much more complicated. I want to create an interface type. What could you do then? What would you do? Okay, I think just hold that thought. I think my progression here is that we can actually solve that problem right now. Okay, let's start. Questions? So, did you see the latest assignment? It's good to always answer the question you just had. Sorry, say that again. Oh, yeah. So what was that? You want to do some? You want to do that? What is your favorite color? What's the right answer? just if you want to do that for extra credit, if you want to put the Monty Python dialogue in there to see whether they actually follow that dialogue, sure. I don't know whether you get points for that or not, but if you want to have fun, sure. Okay, but for now, anything, so that's why you have passed and failed. So somebody says, yes, the answer was right or wrong, and regardless of what the other person had said. So you can have some kind of check that passed is only said if, it follows the script. Okay, but, there's no correct answer to what's your favorite color. So, right, you can say, oh, did they say did they go and hesitate? So you can, you can try to have fun with that. Okay, right now making it simple. When you're testing it out, you don't want that to happen. Okay, you want to just type very quickly and test it out. So you don't want to write the full sentence, what is your favorite color? So that's partly why I made that n variable, because you may want to make n 1 or 0 when testing, just to see if other things are working or not, and then make n equal to 3 if you really want other things. Okay. So we looked at generics last time. And in the recitation, you also looked at generics and you did a problem. And let's go and review that stuff and see whether we really understand generics or not. Okay? So, general idea was that you can have any scope, and interface is one of them, class is another one of them. It could be method, parameterized by type parameters. Okay, so this is interesting that parameters are something we saw in the context of methods, and methods take parameters and they have types. The parameters have types. Now types themselves are parameters at compile time. The types can be parameters at runtime or compile time. These are parameters at compile time. Okay, so generics is all about compile time. It has no effect on runtime. Okay? At runtime, and that's something that's rather confusing. So that can be confusing. Okay, so we said this interface I is parameterized by type T. So we know that T is a placeholder, and we know placeholders are typically in computer science enclosed in angle brackets. So that's what we've done. But once we've declared T as a placeholder at declaration time, we don't have to put a placeholder each time. So now we can just use T where we would have used some other time. Okay, so this is our generic interface. And when we go in, so when we use the interface, this is when we define the interface. Now we have to use the interface. Okay, so we talk of method declaration and method call, right? So here we don't quite call an interface. So inspired by Ada, I use the word elaboration. Okay, so when you use the parameterized scope, okay, then you are, and when that scope happens to be, a type, then you're elaborating that type. Okay, so I've said string I is of type I string. Point I is of type I point. Okay, so now you're assigning essentially to the type parameter a type value. But again, at compile time, this is not runtime. This is very, very important. Okay, and because it's compile time, all elaborations share a single implementation. In the implementation, T is replaced by object. Okay, so it's just like you would have declared put object and you would have done some casting, and now you don't have to do casting because you're doing elaboration. Okay, so again and again I'm saying that. Editing, we did that. I'll do something like this, which I've been doing all the time. Left bracket, something is always a placeholder. I've been using them for non-terminals. I've been using that when we talk with the bean pattern, the vector pattern. So we'll declare history to have some parameter T, which is unspecified when I go and declare history. Okay? And now I will refer to T because I don't have to put angle brackets everywhere here because I've already said this is my parameter. And it says whatever T add element takes as a parameter is the T that element at returns as a value. This is how I specify the bean conventions. I said there's a property P of type T. You have to have get P returning type T. You have to have set P taking value of type T. I was using this implicitly in defining the conventions. And this is something you can actually do in Java.
On the first slide, it was saying that there is no user relationship with, so it was string to string, not a string.
Yes. In fact, the ISA, you're going to spend a long time on what ISA means. And all your intuition about ISA is just going to go out of the window. Okay? And when we see, that's why if somebody says they understand generics, well, probably not. I still don't think I got it. I've got it completely. Okay? But, yeah.
So that generic is used for objects with types which are not related to it.
Yes, I can have point, I can put point here, I can put string here.
So can generics be used without the set relationship?
And if you do them, you'll be surprised. That's what I was just saying. Oh yeah, you can, of course, you can use them.
Okay.
But is there relationships you think that exist between them? Just don't think right now. We'll talk about it. Editing, we did that. I'll do something like this, which I've been doing all the time. Left bracket, something is always a placeholder. I've been using them for non-terminals. I've been using that when we talk with the bean pattern, the vector pattern. So we'll declare history to have some parameter T, which is unspecified when I go and declare history. Okay? And now I will refer to t because I don't have to put angle brackets everywhere here because I've already said this is my parameter. And it says whatever t add element takes as a parameter is the t that element at returns as a value. This is how I specify the bean conventions. I said there's a property p of type t. You have to have get p returning type t. You have to have set p taking value of type t. I was using this implicitly in defining the conventions. And this is something you can actually do in Java.
On the first slide, it was saying that there is no is-a relationship with, so it was string to string, not a string.
Yes. In fact, the is-a, we're going to spend a long time on what is-a means. And all your intuition about is-a is just going to go out of the window. Okay? And when we see, that's why if somebody says they understand generics, well, probably not. I still don't think I got it. I've got it completely. Okay? But, yeah.
So that generic is used for objects with types which are not related to it.
Yes, I can have point, I can put point here, I can put string here.
So can generics be used without the set being relationship?
And if you do them, you'll be surprised. That's what I was just saying. Oh yeah, you can. Of course, you can use them.
Okay.
But is there relationships you think that exist between them? Just don't think right now. We'll talk about it. Okay, questions?
For the assignment 10 part about the effective actor, we don't have any composite shapes. We just arbitrarily give our shapes in different packages.
How can you not have composite shapes?
Well,
What's the composite shape?
it's like a big made up of multiple other shapes.
And you have no composite shape?
Well, I do, but they're not in the shape package, but they're over with the knife or the other body part.
So that's good. Yeah, so that's good. And protected variables is what I expect you will need to use. But if you're not using them, then maybe you aren't inheriting enough from the atomic shapes, and the composite shapes aren't sharing enough code. Maybe. Okay, so just look into that. Yeah. If you put them in different packages, did your generic shape have any variables that are accessed by the other? If you don't, then that's okay. Maybe all your variables are accessed by the methods there, and you don't need them. Okay? But maybe in case you do need them, so I don't know whether I said you should have to use protected variables, but that's something you may need to use. So the main goal right now is to put them in different packages and then see whether you need protected variables.
Okay, but if we don't, then we don't need to worry about it.
You don't have a rubric up there?
Yeah. You will. Early afternoon.
Other things? Okay. So we've looked at a lot of issues with inheritance. And because of inheritance, there's all these complexities in the language. So what happens what? And it's just like having inheritance laws. It's a complicated concept. And we said, well, when a class has to reuse something from another class, so class A needs to reuse something from class B, A can be made a subclass of B, or A can delegate to B. Okay? And when it delegates to B, when you declare class A, it has a variable that references, so who's inheriting from whom? A is sharing from B, right? So A would have a reference to B. Okay, so it has a reference. And we saw that in point history, that we first tried a point history with that extended a history, but then we got that add element which we decided was not what we wanted. It makes sense, but we just decided arbitrarily that we don't want the add element from history. We want our own add element. So we had this add element which took different parameters, and a point history implements a different interface from a history. But to implement its interface, it uses a history. So it delegates to a history, and the analogy I gave to you was, you're delegating to some friend, some coworker, some assistant, and when you delegate, if you're the one who's responsible for it, then maybe you change things from what you got. Okay, so even in inheritance you can override, but here you can do more than overriding. You can change the set of methods that you present. Okay, so this is what delegation is. Now this particular class, it's not doing very much, right? I mean, if a history is the assistant and if point history is the manager, I mean, what's the manager doing? It's forwarding calls. So when it gets element added, just forward. So when you do delegation, by the way, if you don't want to change the implementation of something that you're sharing, you have to write a forwarder method, which is why delegation is a bit of a pain. Okay, but it gives you much more flexibility. You can change the interface, for example. So element add is just forwarding, size is forwarding, add element is doing something, but it's not doing very much. So would you think, can you think of some term? I mean, that it's not doing very much. And can you think of a term to describe what it's doing? It's a messenger. So it's just getting a message and forwarding it. But add element is doing something, right?
I mean, it's just basically returning the message that you forwarded, getting the message back.
But if it would be a pure messenger if its signature was the same signature as that. So
Some sort of converter or adapter.
Converter or adapter. It's like when you go to Europe, you can't just, plug in your laptop. You need an adapter. The adapter is not a power supply. It's not adding any functionality. Okay, it's just adapting. Okay? So this is an example of it. So now I'm using history. Okay, so whenever I use history, I have to go and put something here. Okay, now I could have said a string history, okay, implements history string, in which case I've given it a specific value. Okay, so it's like I have a calculate BMI method that takes a height and weight as a parameter. Then I define a method called calculate my BMI. So I could go and just pass my parameters, and so the calculate my BMI is not parameterized. Or I could write another calculate BMI method that also takes parameters and converts height inches to meters and kg to pounds, or vice versa. And so it's whatever parameters it's getting, it passes them on. So what I did was I said, okay, I have this particular history interface. I can use it in an implements clause. And now I can make a very customized history, or I can make a generic history. As it turns out, the code here doesn't depend also on the type. I mean, it can be applied to many, many types. Okay? So what I'm saying here is that the class history is also parameterized. Whoever's going to use class history is going to provide a parameter. Whatever parameters passed to a history is passed to history the interface. Okay? This is just like my defining a calculate BMI with another height and weight or something else, with just a height maybe, and the weight is, or the vice versa is fixed, and you just pass the buck on. Okay, so that's what's going on here. And you can see now that what you've done here is fairly obvious, okay, where T was string you put, where this type was string you put the name T, okay. So a lot of this is pretty intuitive, and can you see some unintuitive part here? I didn't just take every occurrence of string and replace by T. I have to cast it because contents is declared to be of type. I didn't just say T, new T, max size. Does that make sense? Yeah.
Well,
No. My question is, does it make sense?
the element added, the content is an object array.
Okay, I've decided, once I decide contents to be an object array, I have to cast it. But why did I just not, why didn't I just make that T also? So arrays are not generics. Java doesn't allow us to do that. But that's just an arbitrary rule, or is that a function of some other rule I said earlier? You know, the fewer rules there are that you have to just memorize, the better. That's what distinguished the early languages from the Mayas. Yeah. Yeah, we'll get into that, but the same problem occurs in generics also. We'll see that. So this is you're getting ahead a little bit, but there's some rule I gave you earlier about generics, and from that rule this follows. Something I emphasized again and again at the beginning of the class. What did I emphasize so many times about generics, which I said was confusing? Some can be confusing. Compile, very good. It's a compile time activity, which means at runtime there's only one implementation of that generic. Now, if T was a parameter, if I said new object, then I get an object array. If I said new int, I would get an int array. If I said new double, I would get a double array. And all of these arrays of different sizes, they're different things. Okay? So ultimately, I have to go and say what kind of array I have. I mean, array, allocates storage. So ultimately, the implementation is in terms of object, and this makes it very clear that it is an object array, and it's not some int array or double array which would be represented differently, because objects are stored as pointers, and doubles are not pointers; they're values, and they can be more than the size of a pointer, and short would be less than the size of a pointer. So it's got to decide on what the implementation should be. So you better go and tell it exactly how big that array is. Okay, that's another way of saying that array is not generic. And why is array not generic? Because you could, and in the case of array, you have to sort of decide what the implementation is, and that's what you do. Okay, so there's only one implementation where T is equal to object essentially, and that's what's being made clear. Okay. Questions? Okay. Yeah.
Now, if you have a specific add element method that works for a certain type T, say if you need to add a string, you need to do something to the string or it adds it to this special type of history. But for all the other types T, it can just go ahead and add the element. Is there a way to make a specific method that looks like add element, but only, overrides add element if T is a specific type?
So there are many constraints with using generics. When you, like I said, ultimately, when T is a parameter type, you've got to only apply to T those operations that are shared by all objects. Okay? So you can't do an integery, it's not a word, but you can't do something that an integer requires. Okay? So if your add element expects anything other than an object, I mean, if your add element makes some assumptions about the type, then you can't do it. Okay? And it also has to do with the fact that there's only one implementation. Okay? And that you can assign different types to it later. So if you assign different types, then if you assign a non-integer type, then you're in trouble. Okay?